Hi all, this video is about few moments captured during my studies at IISc Bangalore Electrical Engineering Department. My work was mainly related to induction motor drives and pulse width modulation techniques for the same. I was working on a special machine called split phase or a 6-phase induction motor and exploring the carrier based and space vector based pulse width modulation techniques for the same. I'm not going into much technical details about or explanation about it, as this is not a detailed technical content what I'm giving here. It is just to give a feeling of how the life, the environment and the experiments looks like inside the IISc labs. However, let me give a brief introduction for the sake of video. A split phase induction motor drive is made by splitting the stator windings of the motor, the 3-phase stator windings of the motor, into 2 equal halves to have a spatial angle of 30 degrees. Now these 2 sets of windings are being fed with 2 voltage source inverters, what we call as voltage source inverters, for the speed control. Now the low DC bus voltage requirement for these inverters and some improved torque profiles are some of the advantages of this motor. That was about motor. Let me give a brief introduction about space vector modulation as well. Space vector modulation utilizes switching states of the legs of a voltage source inverter. So it has a top IGBT and a bottom IGBT. Based on which IGBT you're turning on, you can create different states. And that different state in turn creates a rotating space vector, which is an imaginary vector in voltage space. And that in turn creates a rotating flux to control the rotor. Now, when you start the motor, we keep the voltage less so that the inrush current into the motor is very less. And also we keep the frequency also low. So this is basically to avoid underflux or saturation. So as and when the motor picks up speed, voltage is also increased and the frequency is also increased. So you can see throughout the video the V by F, or what we call as voltage by frequency of the motor, what is applied by the voltage source inverter, is kept constant. So without much delay, let me get into the video. Please do note the peaceful environment, the beautiful sounds of the birds in the background, which creates a perfect environment for research in IISc Bangalore. Here I turn on the power to the FPGA which controls the motor. Here the software or the firmware written by me to control the motor is getting loaded into the FPGA. These are the voltage source inverters which are going to control the motor. And this is the split phase induction motor. Already the DC bus have been pre-charged, as you can see in the multimeter. And here it starts. I do love that building up sound. The right side scope shows the current flowing into the motor, and the left side scope shows indicative modulating wave. With every run, it's pleasure to hear this sound and the motor picking up speed. And that's me 13 years back. The motor is slowly getting into a steady state. Here we have attained the steady state. Now we turn off each phase. You can see one by one phase turning off. The motor slowly ramps down due to the friction. Now as usual practice, we turn off the controllers. Hope you have liked the video. If you have liked the usual thing, like, share, subscribe. Hoping to meet you in yet another video. Thank you all.